Hi everybody and welcome to this OpenStack.Ninja OpenStack component overview video. This video is going to walk you through the high-level architecture and the high-level components that make up an OpenStack platform. This video is really targeted at people that are new to OpenStack, as it will just talk at a high level about some of the components that exist and the architecture that may be in place to support an OpenStack platform. Before we start with that though, a little bit about me. So I've been working in IT now for 15 years and I've been working with Ceph and OpenStack now for 5 years. I've designed and implemented multiple OpenStack regions for both public cloud services and private cloud services, and I've mainly worked with Red Hat OpenStack. Now that may mean that some of my content is slightly Red Hat biased, as it's the technology that I know the best. But I will try to be as generic as possible. And also, everything I say in these videos is correct to the best of my knowledge. If you spot any glaringly obvious mistakes or anything that you don't agree with, feel free to reach out to me. I'm happy to have conversations and amend the videos as I go. So very quickly, let's talk about what OpenStack is. OpenStack is a collection of multiple projects, all open source, that allow you to deploy an open source cloud, and allowing customers to, or internal clients to spin up instances and virtual machines and run them on there. It's been in development for over 10 years and it's massively scalable. So if you're interested in the sort of scale that OpenStack platforms can get to, I'd have a look at some of the work that CERN have been doing with OpenStack. And they have an absolutely massive OpenStack deployment, and it's very interesting to have a read about. So yeah, OpenStack is an open source cloud service made up of multiple projects that you can build, that you can kind of tie together to build a cloud platform for you to use. So at a very high level, generally an OpenStack cloud will consist of 3 types of nodes. I'm going to talk very quickly here about controllers and computes, and we'll talk about storage towards the end. So one of the things I'm going to aim to do in these videos is only talk about production scale deployments. A lot of videos I've seen talk about kind of building all-in-ones and that kind of thing. But what I'm trying to do in these videos is explain how a production OpenStack cloud may look. So I will try and talk about high availability and how that's managed and that, as we go through. So, controller nodes, they generally deployed in clusters, and we'll talk about some of the clustering technologies that we use a bit later on. Generally in odd numbers, so you'll see controllers of 3, 5, 7, and that's to allow quorum to be kept between the individual components, and again we'll talk about that a bit later. The controller nodes are where all the brains of the OpenStack platform sit. It's where all the API endpoints sit. It's where all the OpenStack component master services live, and they then pass incoming API. They translate incoming API requests down into actionable workloads for the computes. So controllers, like I say, deployed in clusters, and it's where your API endpoints live and where all the heavy lifting is done on the OpenStack side. Then you have what we call compute nodes. Now, a compute node is where your actual workload runs. So when you build an instance on OpenStack, your instance will actually end up running on a compute host. They generally run KVM as the virtualization technology, although you are able to run Hyper-V, Xen, and ESXi as your hypervisors on your compute nodes as well. And they are scalable from 1 to 1,000, to thousands of compute nodes. Obviously, once you get above a certain number, it becomes more and more difficult to manage, and there's some techniques that you can use, but generally OpenStack is massively scalable. In these videos, when we talk about the hypervisor that's being run on computes, we'll generally be talking about KVM, as that's the most popular choice, but I may mention the others as we go through if there's something interesting to talk about. So before we move on to the OpenStack components that make up a controller, there are quite a few kind of non-OpenStack components that exist in order to support the OpenStack platform. So generally on the controllers, as I said, that's where the majority of the heavy lifting can be done. Generally you're going to see a database service of some type. Generally I've seen that it's MariaDB running a Galera cluster, which means that it's multi-master and that any of the database servers are capable of handling reads and writes. And that's where your static data is stored. So, you know, when you create a user, your user exists in that database, etc. You'll then have a message queue service. Generally, it's RabbitMQ, although there are other technologies and other services that can be run in that place. I've generally seen RabbitMQ in that usage. And RabbitMQ is how the majority of the OpenStack services communicate with each other. So when you send requests into the OpenStack platform via the API and you're asking it to do something, those generally get translated down into a message on a message queue and distributed to the servers that need to deal with that request. Service load balancing. So generally, when you're talking about high availability, you'll normally have something like HA proxy sat in front of the platform that allows requests to be distributed correctly to the member services. This can be done with HA proxy, which is the method that I've seen most, but it can also be done with external load balancers, so something like an F5 and that kind of thing. You'll then find that sat behind that, and when we talk about the different projects in a moment, you'll notice that the majority of them are served by a whiskey application. So you're going to need something to serve those. Generally that's Apache, but it can be Nginx or any other Lightspeed, etc. Generally though, when you're looking through the documentation, you're going to see that Apache is the service that is used the most for kind of web serving. OpenStack also relies on key value store, and Redis is the chosen technology for that. Allows very quick key value storage and retrieval, and used by some of the OpenStack projects to store that kind of data. We were talking about service load balancing and high availability. You'll also find that there's a lot of floating IPs or VIPs, virtual IPs, that exist on an OpenStack platform, and they are normally managed by KeepAliveD, which is a tool that allows you to keep floating IPs in quorum and move them around the platform as a service fails. Depending on some of the configuration settings, you may also find that there's a memcached service running on all of the controllers, and that allows web caching, and again that's configurable per project. Some projects use it, some projects don't. In some OpenStack platforms you may also find a MongoDB instance, again clustered, and that's for kind of storing your non-traditional database items in a NoSQL style database. And lastly, again, depending on how you've deployed your OpenStack platform, you may find that there's a container runtime service running, and all of your items that we've just spoken about may actually be running inside containers. Depending on your flavour of OpenStack, whether or not it's an Red Hat OpenStack or a canonical OpenStack, or whether or not you're rolling your own, it could be Docker, it could be Podman, it could be anything else, any other kind of container runtime. Generally though, it's been Docker. Then one of the other items that you'll notice that runs on an OpenStack controller is going to be Pacemaker and Chorus. So Pacemaker and Chorus work hand in hand to manage kind of cluster components. So when we're looking at the actual OpenStack projects in a moment, we can talk about this a bit more, but basically Pacemaker and Chorus ensure that there's a quorum of servers serving the applications and services that you expect them to be serving. It also manages all the floating IPs and the VIPs that are required, and it's it's just a quorum and clustering technology, and it seems to be the one that OpenStack has settled on. Generally, OpenStack components will run active standby. Some of them run active, but the majority are active standby, and that's all controlled by Pacemaker and Chorus. It just ensures that that we don't end up in a situation where you have two components thinking that they are the live part of the component, and we don't end up with any data corruption. But Pacemaker and Chorus can be its own video. In fact, it's quite a large topic. And then lastly, well, not lastly, but the other thing you're going to notice that's running on controllers is either be OpenVSwitch or OVN, depending on the flavour of OpenStack that you're deploying. OpenVSwitch is a virtual switching technology. Relies on open flow rules to pass traffic between the different components, and it runs on the controllers. It also runs on the compute nodes, and it runs on and it can also run on the storage nodes, depending on what storage nodes you're looking at running. OVN is a fork of OVS, and it's the newer kid on the block. It's all the same features of OpenVSwitch, but it's being kind of targeted at being designed to be used only by cloud platforms. So OpenVSwitch, again, very important technology, and it's how all of your internal networks inside OpenStack will talk to each other. It controls your ingress and egress out of the platform, but we'll talk about that again in a later video when we get more into depth. So we're now actually on to the OpenStack components. So everything else that we just spoke about before are kind of components that need to be that are used by these OpenStack projects to actually provide their service. So we'll just walk through very quickly what these are. So from top left you have Keystone, which is your identity management tool. Identity management project. That handles all of your API authentication and authorization. So when you log into the platform, it's Keystone that verifies that you have access to the projects that you're trying to access. So Keystone is as I say, it's a very important part of the OpenStack platform, and it deals with all of your identity management, all of your authentication, all of your authorization. And it enforces the multi-tenant RBAC and everything to do with users and groups and that kind of thing. You then have Nova, which is the compute service. So Nova is the service that the majority of people interact with, and Nova is what actually provisions OpenStack instances onto a hypervisor. It takes care of all of the KVM configuration, so it creates all of the required files in order to create an instance on an OpenStack hypervisor, and manages the life cycles of instances. So anything you do that relates to an instance will be done via the Nova service. You then have Cinder. So Cinder is a block storage service. It integrates with a large number of different storage technologies in order to provide block storage to OpenStack instances. So as you can imagine, Cinder and Nova work quite closely together. If you're booting a Nova instance and you request that a volume be attached, then the Cinder service will take care of the attaching of the volume, the creation of the volume and the attachment of it to the instance. Cinder has multiple bits to it, and we'll cover that in a later video where we talk about Cinder in depth. But Cinder generally just deals with your block storage. Neutron, which is the network service. So Neutron integrates with OpenVSwitch or OVN and ensures that anything you do with regards to networks inside OpenStack, that's handled by Neutron. So Neutron will ensure that the tunnels between the hypervisors are created correctly so that your instances can talk to each other. We'll make sure that your layer 3 routers to allow you to do north-south traffic routing exist and that they're managed and they're working correctly. Provides DHCP services, metadata services, pretty much anything to do with networking is handled by Neutron. And again, you can imagine that there's quite a lot of overlap between Nova and Neutron. So when you request an instance to be built via Nova, then Nova will speak to Neutron to make sure that there's network ports created on the virtual switches for that instance to be created into. So again, very important piece of componentry, Neutron. It's very complicated. It's probably one of the most complicated parts of the OpenStack infrastructure. And again, I'll be doing a video on Neutron, a deep dive on Neutron later on. Glance is the image service. So Glance allows you to create and store images that you're going to deploy into your OpenStack platform. So generally these will be QCOW images, although OpenStack is capable of taking in a huge plethora of different image types and converting them to a working image for OpenStack. But Glance deals with ensuring that those images are available to be served up to the compute service when it wants to build an instance. Finally, on this page we've got the Horizon dashboard. So OpenStack generally is a load of OpenStack projects that you hang together, and generally they're accessed via an API, but there is also a GUI for it, and that's the Horizon dashboard. Horizon dashboard gives you the opportunity to interact with the OpenStack platform in a kind of GUI banner. It's very straightforward to use, fully customizable, and it can and for those of you that are coming from a kind of a click and a drag and drop or a GUI based environment, then the Horizon dashboard will be probably the first place that you start. The last three services that I'm going to talk about here are HEAT, which is an orchestration engine. So OpenStack has its own built-in templating and orchestration engine, which is called HEAT. It's a very powerful tool. Unfortunately, it does mean that you need to learn another templating language, but it's built into OpenStack and allows you to control all of the OpenStack projects that we've spoken about and all the other OpenStack projects that we haven't spoken about directly through a HEAT, the HEAT engine. It's really interesting. You can use it to do auto scaling, where it takes information from the telemetry service, works out that your instances are running hot, and will automatically build a new instance from a catalog item and deploy that for you. It can also, you can also do things like you can template your builds, and then you can use those heat templates on any other OpenStack cloud. So if you've got multiple OpenStack regions that you work in, maybe you work using two providers and they both have separate OpenStack clouds, you can template your builds using HEAT in one location and then reuse that HEAT template in the other location, and it will automatically deploy a replica of what you've built in the first location. So HEAT, again, really interesting. A really complicated. It's not a difficult templating language to learn. Anybody that understands kind of YAML will be able to pick it up fairly easily. The last two that we're going to talk about are the placement service. So the placement service is part of tracking resource usage inside the OpenStack platform. It's mostly made use of by the Nova service to keep a track of your hypervisor resource usage and resource allocation. And in the Nova video that I'll do, we'll talk about how weighting and scheduling takes place and how that placement service can be used. And then finally, there's a telemetry project which is made up of 3 or 4 different OpenStack projects, which is kind of in flux at the moment. There's a Ceilometer. There's a project called Ceilometer, which allows you to pull metrics and those kind of items off of the individual instances, and we'll talk about and that's really useful for if you need to write a billing engine or a billing platform, or you need to pull off statistics about how your instances are working, you can do that through the telemetry system. So that's it for the high-level overview of the controllers. Now, those of you that have a little bit more experience of OpenStack may know that there are a few more projects that I haven't actually spoken about. Now, there are lots of OpenStack projects. This is kind of a real high overview to give somebody an understanding of what components may exist in order to get a basic OpenStack Cloud up and running. So let's move on to the compute nodes. So the compute nodes, as I said previously, are where your instances actually exist and where they run. Now, on your compute nodes, you are going to find that there are some Nova compute services running there, and some Neutron network services running there. Now, the Nova compute service will be what's speaking to KVM and creating the required configuration files, and ensuring that the instances and passing the instance that you're trying to create or you're trying to modify through the required lifecycle states. And you're also going to find a Neutron service running on that compute node as well. Now, that Neutron service will be speaking to either OVN or OpenVSwitch, again depending on which one you've deployed, and ensuring that all of the networking requirements are in place. So ensuring that the virtual switch has a port for your instance to be created and attached to, ensuring that the tunnels between each of the hypervisors and the controllers are in place to ensure that you've got north-south traffic and that you've also got east-west traffic. And you will also have, as I said before, the KVM service, which will actually be instantiating and running the OpenStack instances that you've asked to be created. So that leaves us with the last item which makes up an OpenStack platform, and that's storage. Now, storage on OpenStack is flexible, very, very flexible. You can use pretty much any of the major SANs that exist in order to provide storage. And I've got some listed here. So you've got NetApp, Dell EMC, 3PAR, Pure. The URL at the bottom there shows which drivers are actually available for the latest version of OpenStack, and that gives you the kind of I think there's about 100 different storage options. So if you're in an environment where you use pure storage arrays, there's a driver for pure storage, and your OpenStack platform can be integrated into your pure storage. If you've got Dell EMC VNX arrays, then you can again integrate with your VNX arrays without a problem. Typically though, you will see OpenStack infrastructures built using or built to use Ceph. Now, Ceph is not an OpenStack project. It's an open source. Well, it's a software-defined storage service. I think it's owned by Red Hat, but it's generally considered to be the storage service of choice when building an OpenStack platform. I've worked with Ceph now for 5 years. It takes a little bit of getting used to, but it's fully distributed. It's horizontally and vertically scalable. It scales to petabyte sizes really easily. Again, if you're interested in kind of seeing how big a Ceph cluster can go, I would recommend again having a read of the CERN document, the CERN available information about Ceph. They make huge use of it. So again, storage, there is no one correct answer for storage, and there is no one correct answer for a lot of questions in OpenStack. There's always lots of ways of doing things. But yeah, so storage, if you've got SAN arrays, you can use a SAN array. If you want to use a software-defined storage service like Ceph, you can use a software-defined storage like Ceph. You don't actually even need to provide storage. If you have storage in your hypervisors and you're happy for your instances to be completely ephemeral, you can do. You can just run the server, run your instances ephemerally. So if you're building, if for instance you were to build an OpenStack platform just to host a static website, and you didn't care about your instances being destroyed if you lost a hypervisor, you can do that. So there we go. So that concludes kind of a really high level overview of the components that make up an OpenStack platform. Like I say, that's not all of the projects that exist inside the OpenStack ecosystem. Head on over to the OpenStack.org website to get a really comprehensive view. I'm hoping to start releasing videos now which will be kind of deep dives into those different components where we talk about them in greater depth. But thank you for watching, and if you have any questions or comments, please do leave a comment below, and if you found this video helpful, please do leave a like. Thank you.